A common potato can power a small light bulb, generating electricity right on your kitchen counter. This surprising electrochemical reaction unlocks a hidden world of energy within everyday ingredients. Most people consider food purely for sustenance, fueling our bodies with essential nutrients and calories. However, every bite also represents a complex package of stored chemical energy, much like a tiny biological battery. Cooking itself transforms these chemical compounds, altering their energy potential and accessibility for our systems. Understanding this unseen chemical power reveals the true science behind every delicious meal we prepare. From a simple sugar crystal to a complex protein, each molecule holds electrons poised for energetic reactions. These reactions drive flavor development, texture changes, and nutrient availability during culinary processes. Imagine unlocking these molecular secrets to elevate your cooking and truly appreciate food's hidden capabilities. The humble kitchen becomes a fascinating laboratory where surprising electrical phenomena unfold constantly. Consider the classic potato battery, a perfect demonstration of food's electrical potential using simple components. You need two different metals, typically zinc and copper, inserted into the potato flesh to create the electrodes. The potato acts as an electrolyte, a medium allowing ions to move and complete an electrical circuit effectively. Zinc atoms readily release electrons, becoming positively charged zinc ions that dissolve into the potato's acidic interior. These freed electrons travel through an external wire towards the copper electrode, powering a small LED along the path. At the copper electrode, hydrogen ions from the potato's acid accept these electrons, forming hydrogen gas bubbles. This continuous flow of electrons from zinc to copper, mediated by the potato, generates a measurable electric current. But that's not the strangest part. This same fundamental principle underpins all energy storage in living systems. Our bodies operate on an electrochemical basis, extracting energy from food through a series of controlled redox reactions. Redox reactions involve the transfer of electrons, where one molecule loses electrons oxidation and another gains them reduction. Think of glucose, a simple sugar, as a fully charged chemical battery ready to power your cellular machinery. During digestion, enzymes systematically break down complex food molecules into smaller, energy-rich components like glucose. These glucose molecules then enter a metabolic pathway called glycolysis, the first step in energy extraction. Glycolysis partially oxidizes glucose, releasing a small amount of energy and producing pyruvate, along with some electron carriers. These electron carriers, like NAD and FAD2, are essentially miniature rechargeable batteries, holding high-energy electrons. Wait until you hear what comes next about how these tiny batteries deliver their massive energy payload. The electron transport chain, located within cellular mitochondria, is where these electron carriers unload their cargo. It's like a cascading waterfall of electrons, moving from one protein complex to the next, releasing energy incrementally. Each electron transfer pumps protons across a membrane, creating a powerful electrochemical gradient, much like a dam. This proton gradient represents potential energy, a stored charge waiting to be converted into usable cellular fuel. Finally, an enzyme called ATP synthase harnesses this gradient, allowing protons to flow back and generate ATP molecules. ATP, or adenosine triphosphate, is the universal energy currency of the cell, directly powering muscle contraction and thought. So every time you eat, your body is effectively running an intricate biological battery system, constantly charging and discharging. This intricate dance of electrons and ions isn't just internal, it influences cooking outcomes dramatically. Consider the browning of bread, a Maillard reaction driven by chemical changes involving sugars and amino acids. These reactions rearrange molecular structures, creating new flavor compounds and altering the food's energetic profile. The sizzling sound of frying meat signifies rapid energy transfer and the formation of new aromatic molecules. And then something unexpected happened, as scientists began applying these electrochemical insights to food preservation. Certain acidic marinades, for example, can tenderize meat by subtly altering protein structures through ion exchange. This process subtly modifies the meat's internal battery by changing its chemical environment and reactivity. Electrochemical sensors are even developed to detect food spoilage, monitoring changes in redox potential as food degrades. These sensors essentially measure the food's charge, indicating when its chemical energy system is breaking down. Even fermentation, like making sourdough, relies on microorganisms performing redox reactions, transforming simple sugars. They generate acids and gases, altering the dough's structure and flavor profile through a complex chemical interplay. This constant chemical activity transforms simple ingredients into complex, delicious, and energetically potent meals. Understanding food as a battery system fundamentally changes how we approach cooking and nutrition daily. It emphasizes the importance of ingredient selection, recognizing that each component contributes unique chemical potential. For instance, the antioxidants in berries are electron donors, protecting our cells from damaging oxidative reactions. Cooking methods significantly influence this stored energy, impacting nutrient bioavailability and overall flavor development. High-heat cooking, while delicious, can sometimes degrade delicate vitamins and alter beneficial antioxidant compounds. Conversely, precise temperature control, like sous vide, can optimize enzyme activity, enhancing tenderness and flavor without overprocessing. This meticulous approach preserves more of the food's inherent charge, maintaining its nutritional and energetic integrity. Chefs who grasp these electrochemical nuances can intentionally manipulate ingredients to achieve unparalleled culinary results. They understand how to balance acidity and alkalinity, influencing chemical reactions that unlock specific flavors and textures. Imagine creating dishes where every ingredient is optimized for its energetic contribution, both to taste and health. This deeper scientific appreciation makes every cooking decision a calculated step in a grand chemical experiment. From marinating to fermentation, every technique leverages distinct electrochemical principles to enhance our food. It also highlights the incredible efficiency of biological systems in extracting and utilizing energy from diverse sources. Our bodies are master chemists, converting the chaotic energy of food into the precise energy required for life. This knowledge empowers consumers to make more informed choices about what they eat and how it's prepared. They can seek out foods rich in specific electron donors or acceptors, optimizing their personal biological batteries. The future of food science heavily relies on these electrochemical insights, driving innovations in taste and sustainability. Scientists are developing new ways to harness food's innate energy, potentially creating self-powered packaging or smart kitchen devices. Imagine food containers that generate a tiny current to keep contents fresh longer, extending shelf life dramatically. This fascinating intersection of food, chemistry, and electricity offers endless possibilities for culinary exploration and technological advancement. It transforms the mundane act of eating into an appreciation for the complex, beautiful science powering our world. Every meal becomes a testament to the invisible forces of nature, meticulously working to sustain and delight us. From generating electricity in a potato to fueling our every thought, food is undeniably a marvel of chemical energy. This hidden battery power orchestrates everything from flavor creation to life itself, connecting us deeply to the world. If you found this exploration of food's electrical secrets fascinating, subscribe for more incredible scientific discoveries and share your thoughts below.